Hello everyone, and thank you for joining us today for this new GigaOM webinar. Today we'll talk about breaking storage trade-offs with do-it-all storage. Is it really possible? I'm Enrico Signoretti, analyst for GigaOM Research, and joining me today, Jeff Denworth, CMO at VAST Data. Hi Jeff, how are you today?
I'm great, Enrico. How are you today?
I'm feeling good, and I'm looking forward to this conversation. And just to give you an idea of what is going to happen after a very first interaction, we will talk about storage tiers and why it is time to eliminate them, the new technology and benefits and limitation to work around these challenges posed by tiers in storage, new storage paradigms to enable true consolidation of data, and new architecture, best practices, and question and answers. In fact, I want to make this very interactive. This is a live conversation between me and Jeff, but you have a chat window, a question tab on the webinar tool. You can add your question, we will answer to them. And also we have a few polls that we will run during this webinar. So without any further ado, let's start with the first poll. So looking at your storage capacity today, so the capacity that you have in your IT environment, in your infrastructure, how big is your infrastructure? Less than 1 petabyte, between 1 and 2 petabytes, between 2 and 5 petabytes, between 5 and 10 petabytes, or more than 10 petabytes. Jeff, so looking at VAST and the kind of users that you're targeting the most, what is the the sweet spot for your solution, or what are the type of customers that usually ask you about VAST?
Sure. It's interesting because if you ask customers today how much flash infrastructure they have, it's typically a relatively small portion of their overall capacity that they manage. And the whole discussion today is around tier consolidation. And once you start to widen the aperture and you see a larger lens of capacity through all the types of different storage that customers manage, usually you get a pretty big number. Yesterday I had 3 customer meetings. I would say the average capacity managed by those customers was around 100 petabytes. So these are all obviously very large organizations. And so our minimum entry point tends to start at a few hundred terabytes. Last quarter, I put out a tweet. I guess I put it out last week, Enrico. And what I said was we received 2 orders from customers where they had combined, just those 2 orders were $20 million of software.
Yeah, I saw that.
So, we tend to swing pretty high on the scalability spectrum. I think if you combined up the capacity of those 2 systems, you're talking about probably close to 100 petabytes of infrastructure. So,
Well, I have to be honest. So looking also at the results, less than 1 petabyte is still a lot of, a lot. But if you start considering everything you have, I mean, active data, secondary data, tertiary data, copies everywhere, who doesn't have 1 petabyte of storage? And most of the time, we don't know yet. We don't know it. I mean, when I talk with my clients, and it happens very often. I mean, they don't count all the storage they have. They count only the active storage, the primary storage, what we define primary storage. So let's dive into the technology, into the problems that we have today with our storage to see what is really the challenge and what we can do to solve it. So I think everyone is familiar with this picture, the pyramid with all the tiers of storage, where you have all these storage tiers starting from the hottest one, your tier 0, tier 1 storage, where you have flash, we have very active data, down to tape, cloud, or whatever is your cold storage. Storage tiers are there. Storage tiers are complicated because there are a lot of challenges around it. Okay, you can use automating tiering techniques to move data around. So when you access data very often, you move data to the upper layers, and then when it becomes cold again, it goes down. It's not easy. Usually automatic tiering is something that is in a single system, and we started seeing it a few years back with the first flash system. So flash was the hot tier, and hard drives were the cold tier. Okay, and we saw a lot of issues. Okay, especially if you have some workloads that run for a few days per month, for example, and data goes down in the hard drives, and then you have a lot of latency issues for the first day. And when you're done with your work, then again, when your hot tier is fully populated, actually they are there doing nothing for 1 month, and they go down again. So this was just an example. Then you can have external tiers, so an external system to do the same thing, but actually you have two systems to manage, and no longer one, and in some cases more than one, which is even more complicated. Or you can have HSM. I mean, it's not that popular anymore, but actually hierarchical storage management means that you move your data in the backend. There is a software that does it and leaves a stub in the hot tier that could be recalled by clicking it if it's a file, or in other ways. But actually, again, it's a layer, it's something that you have to manage. It includes several systems, and some of them are very slow. Sometimes we are talking about tapes, so to fetch the data on tapes could take minutes, sometimes hours. And then there is manual tiering, archiving. So you start having huge amounts of data in your enterprises, and you start thinking, how do I move this stuff? Where I put it? There are software that helps you to move this stuff around. There are archiving solutions. There are a lot of potential solutions, but many of them have huge drawbacks. Okay, so you don't have your data when it's necessary, but you have to search, you have to ask somebody. The process gets complicated, and everybody says, oh, I don't need this, we can archive this data, and then the day later you need it, and you lose time waiting, and nobody wants to do it. So productivity goes down. So it's silos. Everything is silos. So this pyramid is not just a pyramid, it's a huge amount of silos. And I don't know, Jeff, but I gave a picture that is what I find with customers of all sizes. I mean, starting from the smallest to the largest here. Is it something that you see? Did I miss something here?
No, actually, I really like this graphic for reasons that we mentally, it's easy to go to this place where you have one type of storage system and maybe one storage system per tier, right? And that's kind of the easy way to think about it, because you can put a class of media and potentially a vendor next to each layer of the tier. You cut it horizontally, and you think, okay, that's pretty simple to understand. But then we start working with these customers, for example, that may have like some flash systems. And they don't just have one flash system, because they're not dealing with scalable infrastructures. They may have like, let's say 10 different flash systems, all designed for different workloads and different applications in their environment. And even though that's their tier, let's say their hot tier, there's just a whole proliferation of silos within that tier, because most systems aren't designed for very high levels of scale, and are not able to give very high levels of QoS at scale. So people tend to just err on the side of building independent systems. And so, yeah, I think this manual tiering and archiving is a problem. The manual part is it has to happen either way, regardless of whether you have an automated or a kind of a script-based approach to managing your data up and down these different tiers of infrastructure. And the reason for that is that at the end of the day, somebody has to make the decision on how data can be classified as either valuable or less valuable. And so maybe that classification is ultimately a function of a policy that gets set into an automated tiering system, but it has to happen either way. And people are always involved in this process of prioritizing and deprioritizing their data, which is, obviously has some challenges.
Yeah, and there are several examples, and maybe we'll touch on a few of them during this webinar.
Sure.
So what are the challenges here when we talk about this pyramid, all these silos? So, and data protection is the first challenge. I mean, having one system to protect is easier than having 20, 30, hundreds, okay? So that's different protection policies, different systems, different methods to access the data. So it could be complicated. And that's not enough. I mean, security is another aspect, okay? So think about different access methods, again, different ACLs, different way to protect the data, different way to manage a snapshot, for example, et cetera, et cetera. So, and now with ransomware, with all these different attacks that can really hamper our way to do business, this is something that we have to think. We have to keep it simple, because the first thing that you want with security, keep it simple. And efficiency, again, we always talk about compression, the duplication, and many other mechanisms to improve, the data footprint efficiency. But actually, look at it. If you have 10 systems, how can be more efficient than having a single system with global deduplication? Okay, so your efficiency could be way better. And system management, I don't have to tell you anything here. I mean, managing one system is better than managing 10 or 20 or again hundreds. And data management is another big thing. Okay, everything about data management, I wrote it in all my report, is about consolidating data. If you know where data is, it's easier to manage it. Some people, some of my clients, when we talk about data management, the first problem is, where do we have data? How it is accessed? How are we storing it, et cetera, et cetera? So there are basic questions that are hard to answer if you don't know where your data is. And life cycle management. I mean, different systems mean different life cycles. So your block storage has a different lifespan that the object storage that you have for storing the data that lasts forever, and scale out system work different than scale up, controllers, firmwares, and so on. That's another long story. We can have a webinar just on that. And and probably there is more. And again, I will ask you, Jeff, is this the same kind of problems that you see in the field? What are the most interesting aspects of VAST Data, or what your customers report about all these challenges after adopting your system?
Well, we hear them before, which is usually the reason that we get brought to the table, and is one of the reasons that we're the fastest growing company in the history of storage. And I think ultimately it boils down to two fundamental concerns. The first is the amount of people, application, and user time associated with reconciling all these different systems, right? To your point, Enrico, if you have to, even ask the question, where is my data? You're in a pretty bad spot. And so having consolidated infrastructure helps you at least get to a single source of truth. I like to use the term archive in that regard, and people tend to associate the term archive with being slow, but if you look in the dictionary, an archive is just the authority of information. It doesn't actually have to be slow. People just have thought it's slow because you want to cost optimize your capacity infrastructure up until now. And so, at the end of the day, the human capital and the app and the kind of the user hurdles that have to be jumped over in order to accommodate tiering are non-trivial. We've got a customer that has about I think about 50 petabytes of infrastructure, And they have an all-flash file system, they have a nearline file system, and then they have a big object storage system that is where they put their capacity. Flash is super expensive, the nearline is kind of expensive, and the object storage is cheap. And this is an organization that has, on a daily basis, a team of 6 people sitting in a room talking about where their directories need to be moved up and down this pyramid. Imagine just having a team have to meet daily for hours just to deal with this problem. You know, I think that there's more valuable problems that organizations should be solving now. And you know, the second element of this is the most critical, where if you think about the modern application agenda, as we move into an era of big data and AI computing, the difference between how we used to compute and how we compute today is that these applications, they get more accurate and they get more effective as they get exposed to larger data sets, right? That's the nature of big data, right? If you can see the full reality of the world, then you can develop the most accurate analysis of that world. And so the challenge becomes that a lot of organizations, as they start to adopt these new applications, they realize that the payload, the most important thing to execute these algorithms, is trapped in their slowest storage tiers. And it really hinders the application agenda. We've got a project we're working on right now. It's an exabyte scale archive, and I can tell you that it's for an AI application, and that application needs to go to an all-flash archive. We were talking with a few of our partners on this, and they said, well, I thought you said it was an archive. And I came back to that statement I made earlier, which is, sure, archive is just a source of truth. It doesn't have to be slow. And in the modern era, I believe it can't be slow.
Yeah, and there is more to that in the next part of the webinar. So before going to that, another quick poll. So how important is your data? So primary data is mission critical, secondary data not that much, so you can live without that. Tertiary data could be deleted anyway, so we are talking about copies of copies, and other stuff that sits around for a long time. Long-term backup archives are not really important. You can really live, your company can live without this data. We have a no delete policy, so you keep everything, but you're storing a lot of useless data, and you know that. All my data is critical for my business. Okay, so let's start to see what you say. This is a very provocative question, and I tell you that because many of us already heard about the story about all oil and gas companies not long ago retrieving very old backups, very old data, like 20, 30 years old backups that they built during their data collection through exploration. They never use it again. Actually, they found a way to reuse it now, because instead of sending again ships and sonars and stuff and drilling and whatever, now they can use AI, they use some analytics technique that were not available 30 years ago, and they need the data now. Okay, so everything is important then, from my point of view. What is your opinion?
Well, you know, we're dealing in anecdotes right now, so I've got an awesome one. We have a customer that's a sports broadcaster, and last year, you know, the whole professional sports thing came to a quick halt. And this is an organization that needed to go and keep delivering content so they could keep the ad revenue going. And what they realized they could do, because their data was on their archive was on a flash system, is they could immediately go and start to refactor it. And in this case, what it meant is, A, they wanted to go and create new content from the data, but B, they were going and replacing the advertisements on the old footage with a lot of advertisers that weren't paying the bills anymore with new advertisements from new advertisers that would pay the bills for this content. And they kind of believed the only way they could do that is if it was on flash infrastructure. So that was an awesome story, I think.
Yeah, let's see the results before going to the next. So primary data is mission critical, and secondary data not as much, got the second place. Actually, all my data is critical, in fact, got 43%. So why we asked you this question? And let's go to the next section of the webinar and see why. So how do you define primary and secondary data? Actually, there was an animation here. I don't know why it doesn't work, but so usually the problem that we had in the last few years was to define what was primary and what was secondary. And in many cases, primary was your database, and secondary data was files, maybe accessed by users, and other unstructured data. But actually, in the last few years, we discovered that all the data is primary, okay? And because of that, there is no more distinction about primary storage, which was in the past block storage, and secondary storage, which was your filer or your object store. Okay, now all your data is primary. Think about, you Jeff mentioned AI workloads on a massive repository. Isn't it primary data in the end? I mean, isn't it necessary to run your business? Is it necessary to drive additional innovation and, you know, be more competitive now? So everything. Go ahead, sorry.
I think AI is an abstract concept for a lot of organizations still, right? It's coming, but it's not everywhere. But if you think about like just the internet, the internet is largely built on object storage anymore. So if you think about like your average photo site or social networking site, they're trading in object storage as their primary kind of like engagement vehicle. And without that type of infrastructure, there would be no business. So I don't see the distinctions either, Enrico. I think you called it really right. You can't put in place protocols and privacy.
This year we had at GigaOM had this object storage report, and we had to split into two radars, to market landscape, one for traditional object storage and one for high performance object storage, because the demand for high performance object storage is rising like crazy. So that's a point. So it's no longer, you know, the type of storage. It's all about the data, and all the data is becoming primary. So let's talk about the storage technology. Let's see how this pyramid is actually composed today. Okay, and we have now storage class memory. You probably are already familiar with the commercial product Intel Optane. Okay, this is something that sits between RAM and NVMe storage. It could be even in the memory bus, and so it's very fast. It's the only problem that it has, it's quite expensive. Okay, so it's very fast but expensive compared to other forms of storage, persistent storage that we have. And the other types of memory that we have is flash memory. Of course, MLC, TLC is what runs on our block storage, so the tier 1 storage that we have in our data centers now. A lot of dollar per IOPS, so the dollar per IOPS is very good, but the capacity is not always there. It's quite expensive. Of course, you can have the duplication, compression, and so on, but again, not always, you know, what you would love to have for your storage. Then there is this new QLC memory, quad cell memory. So QLC has some of the benefits of MLC and TLC, but actually it doesn't have the endurance. So you have a very good dollar per gigabyte because it's way denser than the other types of NAND memory, but durability is Achilles heel. And then we still have hard disk drives. Hard disk drive, again, dollar per gigabyte is very good, but the performance it's not there. There is an effort from the hard drive manufacturer to improve performance, but actually it complicates how you access and manage this drive. So it's not for everybody. Of course, it's not for daily usage in the enterprise. And then there is the cloud. The cloud, of course, could be flexible but unpredictable in the sense that especially when it comes to the cost or latency, or there are a few issues that can come up later when you adopt the cloud. Tape is another media that is with us since the beginning of time now, and tape is really cheap, but it's slow. And would you start a tape infrastructure today if you are not familiar with tapes? You don't know all the challenges that this kind of media brings to your IT organization? I don't know. So this is a very complex scenario with a lot of types of media and a lot of challenges for each one of them. So yes, fast, capacity, durability. So there are a lot of very complex. So it's very challenging combining performance and capacity. And when we talk about absolute performance today, we talk about storage class memory. And when we talk about capacity, look, we are not talking about hard drives anymore, but QLC. I have to say that QLC is not as cheap as hard drives, but if you start putting together the fact that is more dense and consume less power, then you start having benefits around the TCO, for example. And there are a few other things that we will discover later that will help again with the dollar per gigabyte. So well, this one was very long on my side, Jeff, but I think you agree with me about storage class memory and QLC, don't you?
I do. And you can kind of take this pyramid and also add a whole dimension, which is like the different types of systems that you can buy that are composed of these different technologies. So it's really tough for customers to find, like you said, simple solutions when they're presented with all these different options and trade-offs.
Exactly. So the best of two worlds, we already mentioned storage class memory and low latency, and we are talking about microseconds if it's in the PCI bus, so it's very low latency. And IOPS, we are talking about millions of IOPS. In some cases, you don't even need millions of IOPS, but actually each single device can provide millions of IOPS. So you don't have bottlenecks, and it's very durable. I mean, it's the most durable type of memory that we have today. So we don't have the issues about multiple writes or things like that. And it's also, again, because it's fast, we can rewrite the same information multiple times without having all the issues that maybe we can have with QLC, because the way it's organized. But again, this is very expensive. Okay, it could cost like 10 times what it costs other storage media sometimes. So it's not that you can build everything on top of it. On the other hand, you have QLC flash memory. Okay, so QLC is can bring you a lot of capacity. Now there are vendors talking about drives up to 30 terabytes, so they are huge. The problem with the QLC is that even if they can give you a good number of IOPS, so in terms of read operations, they are pretty poor in writes. And this happens because it takes a lot to write the memory cell. We won't go deep in this, but actually the process to write a QLC flash memory cell is very long, and The other advantage is low dollar per gigabyte. Okay, so compared to TLC, MLC, and especially storage class memory, this is very low and going down. Actually, so the price per terabyte of hard drives is not going down that quick. So we will have a moment in time in the not in the distant future where the dollar per gigabyte will be good enough, even if you don't have the advantages of the duplication and other optimizations. And the huge problem about QLC is minimum durability. I mean, we are talking about very few writing cycles on the single cell. So you have to organize everything carefully before writing, and not waste any single write. Jeff, when you will talk about all of this, okay, maybe you can shed some light on how VAST is taking advantage of these two media, because we didn't mention it yet, but this is at the core of your architecture.
It is. It is. You know, so our mission is to kill the hard drive. I think that's kind of what we started the company to do. When we began, what we concluded was that customers weren't really so focused on getting a few more microseconds out of their flash infrastructure. Most of the time they were buying flash for capacity. They got more performance from what they needed. But on the flip side, every one of them was complaining about the cost of flash capacity. And so we basically set our mind to trying to solve the capacity cost problem and building a system that could be cost effective with hybrid or even hard drive based storage. And I think we've gotten there. But one of the things that we kind of set as a primary objective for the architecture that we built is to make use of really low cost commodity flash. And you said it's not to the price of hard drives yet. And I think that's true, Enrico. QLC probably carries a 3 to 4x premium over top of a hard drive, a high capacity hard drive today. But there are some other things that can be done with QLC that I think people tend to forget. One of those is that you can keep the devices on the floor for much longer than hard drives. In fact, we support them for a decade. And you mentioned data reduction, but I think the thing that the first generation of flash arrays showed us is that with flash, you get the benefit of random access media. And once you don't care about IOPS, you can start really dramatically reducing your data sets by implementing a new class of data reduction algorithms that if you ran them on hard drives, you basically fragment your data and it would be impossible to read off these drives. And so next generation data reduction layers on top of next generation kind of longevity and amortization cycles on infrastructure to get you to a point where you really can't afford QLC for all of your data, but the problems, as you mentioned earlier, are durability. If yesterday's flash drives and hard drives before them were meant to be written to in 4K sectors, these new flash drives, these QLC drives, in order to get to the capacity points that they need to get to, you have to write to them in 1 gigabyte chunks. And no legacy storage system ever even conceived of writing in 1 gigabyte chunks. Actually, most flash systems are designed for the opposite pattern, where you want IOPS from these drives, so you write in really, really small increments. And so we basically needed to build a system that could shape writes into the worst, lowest endurance, lowest durability flash that we could get our hands on. And actually, in the earliest days, we were shipping laptop flash. And the way that we do that is with storage class memory. And so, I think the durability part is the part that we really value with respect to storage class memory. The fact that you can get a level of endurance that's roughly, I want to make sure I do the math right, 300 times better than a QLC drive. And so what we do is we use this new type of Optane memory, as well as just kind of very high endurance flash. We have support for both options. In these cases, like you basically get the time to shape writes as they go down to these drives. And we built this new data layout architecture that allows us to write really large write stripes and organize data within these write stripes that has a common life expectancy, so that we don't have to move data all around the system when stuff starts to get deleted, because the data in specific regions all gets deleted around the same time, and it's really clean. And so you're right, it's the hot tier would be way too small if it was built from storage class memory. Durability is a challenge if you apply legacy algorithms, legacy storage algorithms on top of this new QLC flash. But if you can build an architecture from the ground up to support this low endurance media, then there's some pretty spectacular things that can happen. And actually, after we started shipping our approach that we call Foresight, which is really intelligent placement of data within QLC erase blocks, what happened is that we showed the world that you can get 20 times the longevity out of these drives than what everybody originally thought. And actually, Intel, we use Intel QLC flash, and Intel actually started publishing a second endurance rating that indicated as such. So that allows you to get to 10 years of longevity on drives that other storage systems can't use for even just a few months.
Yeah, and consider that you mentioned it. I mean, Intel is pushing hard on this kind of architecture now. I mean, so that there is storage class memory, and QLC is a sort of best scenario that they are pushing. Of course, they are, you know, selling both storage.
And in fact, you know, there's even other systems that aren't VAST that are starting to conform to this type of approach. There's a vSAN architecture that consists of both storage class memory and QLC that, you know, now you're talking about just standard virtualization infrastructure. You're not talking about VAST, but other people are starting to get on this bandwagon.
In general, I think we are going there. I mean, so that we have the elements now, and just how you combine them is becoming important. I mean, that's the thing. So if we go again, how to combine storage class memory and QLC, there are a few things that are important. So let's talk again about storage class memory. You can use it as a cache or a staging area. And when I talk about the staging area, it's like you use the storage class memory as a temporary area where you can do all these operations that we mentioned. So you can have you can give a knowledge about your write to the servers, and then do compression, the duplication, whatever you need to make the data more usable in the backend. And you use it for IOPS again, writes. We mentioned this multiple times. And then you have the QLC, and the QLC, it's maybe you can use it for reads. So you don't have, think about what I said at the very beginning. So one of the problems that we have with multi-tiering was the fact that if you needed something that was in the capacity tier, it was slow anyway. And if it was your SAP, at the end of the month, you have to do, you know, an inventory or something.
A reconciliation.
It was a problem. Okay, it was a big problem. So you have to preload the cache, or you know, I lived that time, so I know all the kind of problems that you can have. But actually, if you need to read the data and it's already in a fast media, you know, and the fast media is your capacity here, so you don't have this problem. And again, so with the combination of technologies that we took it, you have to find a way to minimize writes. So Jeff, probably you already told me that. There are additional considerations that we have to need to do today. So scale out design, I think it's a must for most applications now. Nobody can think about a scale up system anymore when we talk about, especially when we talk about unstructured data. So thinking about building a system that has a, you know, can reach a limit, and then what do you do? So a forklift upgrade, do you upgrade the controllers and then keep adding other storage, but sooner or later you will reach a limit? So you want to keep it simple. And now scale out is simple because it's no longer like in the past. I mean, it's way easier than a few years back to add additional systems nodes to a cluster, make it work there, and interfaces are way simpler than in the past, or less common line interface to do operations, etc., etc. So scale out is the way to go. And optimizations, we talked about this multiple times. So the duplication, compression, everything that can help to reduce the impact of data on the backend of the system. And multi-protocol, which means having a not changing too much your application, for example. So giving multiple protocols to the application, to the user, so they can access data. And it's also good if you can look at systems that have parity, access parity between protocols. So maybe you want to save data through object storage protocol and read it via NFS. Why that? Because maybe you have IoT devices all across the world, and for them it's easier to use S3, which is based on HTTP protocol, to send data over. But actually, when you need to do analytics on top of this data, you prefer to use NFS locally because maybe it's faster, or because your application are written to use a file system. And then analytics, okay? So with consolidation comes the fact that you have a lot of data in the same system. So you want to analyze workloads, you want to analyze user behaviors and everything. This also has a security aspect around it, because analyzing what is happening in the system can help you to do a lot of things. I mean, I described, let's say, a very complex system, so many characteristics of the system. And Jeff, do you have something to add here? Did I miss something?
No, I think you characterized it. I think one of the things that we think about, you know, as I mentioned, we tend to rotate more towards scale. QoS and performance scalability becomes really interesting, right? A lot of people have scale out designs, but what we've done through disaggregation principles, by kind of decoupling the compute layer from the state of the system and making it possible for all of the machines that are managing the namespace, they don't have to talk to each other. I think one of the things that we've done is we've kind of shown the world that you can build scale out storage infrastructure that's much simpler by eliminating east-west traffic in large scale clusters. And so now that you don't have machines talking to each other, trying to coordinate updates or sharing cache within an environment, what happens is really twofold. One is you can get to linear performance scaling, which actually becomes really important because a lot of the conventional scale out designs, as you start to scale up the load on them, particularly to like common directories or common buckets, what happens is you get a law of diminishing returns of performance. But the other thing that happens is as clusters start to get hot, that heat starts to get broadcast across all of the other nodes within the cluster that are kind of participating in servicing the IO. And so this kind of stateless design that we have is critical for the probably the fifth element that's not listed here, which is quality of service, right? If you're going to go and you're going to take customers to this consolidated end state, you need to be able to not take away performance that they'd otherwise get from having all these different islands of storage infrastructure. And so we've been implementing quality of service with a lot of our customers by decomposing the system and basically applying CPUs to different workloads through a concept that we call pooling. And if you don't have those types of controls, then it's oftentimes, I think, really impractical to start to embark upon this consolidation event.
I totally agree with you. I mean, yes, I missed that one. And,
no, that's okay.
It's also, you know, when you talk with a lot of storage system administrators, and many of them in the past had issues with quality of services. Okay, it was not implemented at the core of the system, so there were a lot of trade-offs. And I think it's you're right. I mean, we are now so used to these silos where quality of service, and very few workloads in each single system, so multiple system with a few workers for each single system, that we don't think about quality of service as important anymore. And when we talk about scale out system, most of the time, we talk about object storage, we talk about very large capacities that use parallelism to provide throughput. So you don't think about quality of service. But actually, if you start having a massive consolidation with totally different types of data consolidated in the same system, then you have different application, and of course prioritizing data becomes, access to data becomes mandatory. So
right, you wouldn't host your data warehouse and your database on the same storage in most cases, because they're very conflicting requirements. One is you have like a batch processing system that is kind of working through its jobs and just driving throughput into the infrastructure. On the other side, you have a transaction system that is just trying to, increment its rows into the system. And if those share infrastructure, the batch workload could just overwhelm anything in a conventional type of architecture. So people haven't even thought that you could really consolidate while still enabling performance fairness.
Yeah, indeed. Question and answer. So we got a couple of questions from our audience here. The first question, I think, is well, the first one was just a comment. I mean, tape is not only slow, but it's strictly sequential, and it is true. Actually, it's not 100% true now, because there are some gateways that help you, and file system that can be built on top of tapes that can ease this part of the tape, but still we are talking about a very complex device to manage in the end, even if the cost is really low and still the lowest of the market. So the other question is probably for you, Jeff. You mentioned that you can start really small, but how small is actually is
small? Yeah, sure. So the system is designed, well, actually our commercial model is kind of different from how everybody typically buys or sells systems in the marketplace today. We announced this new program called Gemini, where what you have is hardware that gets sourced from our manufacturers that we work with at cost. We don't actually sell the hardware, and then customers just license capacity over top of that. And so the unit of capacity licenses that we sell today is as little as 100 terabytes and as little as 1 month.
Okay, this is very small. And so another question is more generic and is about the architecture. And if I read it right, so QLC and Optane living together, in general terms, I agree. I don't see many solutions out there implementing it. Yes, I mean, VAST is an example, but there are other vendors implementing a similar technology, maybe different use cases, not all about scalability and performance, but even Intel is pushing this type of architecture design with many of its partners. Jeff mentioned VMware earlier, so VMware is not there yet. I mean, QLC is not supported yet, but actually,
sure it is. Sure it is.
Sorry?
Sure it is. You can build a vSAN cluster on QLC today. It is supported.
Are you sure? Okay, because I was with some people from VMware and they told me the contrary. That's maybe it's okay. I don't know. Let's say that we can check it out. But the idea is that there are other vendors that are doing other things with Optane and QLC. So it's available for different type of system. Of course, we talk about do-it-all storage, but and Jeff agrees with me, I think. So do-it-all storage doesn't mean that you can actually do it all, because there are a few workloads that maybe you can keep separated for several reasons, especially if they are at the edge. For example, you don't have probably VAST at the edge if you have a 10 terabyte or 1 terabyte cluster. But actually, the idea in general is that this kind of architecture could solve maybe 80–90% of your problems. So you radically simplify your infrastructure by putting by pulling together these kind of resources and a solution that can, really offer a storage service to every kind of application you have in your infrastructure. Am I right, Jeff?
We call the concept universal storage because we don't really see limits to the application of it. We have customers running Oracle on our systems. We have customers running VMware on our systems. We have customers running AI or backup jobs on our system. It really is very broad. Is it 100% applicable to everything? No, we don't offer a block device. So there's still a few applications that require things like SCSI reservations and block protocol support. But, to your point, Enrico, it's 90% of the workloads that you find in the data center. And what we see is that as customers buy the system for one use case, they just start adding more and more incrementally. But I wanted to comment on that comment that came in earlier about how you don't find this combination of technologies typically put together. You don't find a system that's built with a container first disaggregated architecture. You don't find a system built internally of NVMe over fabrics, which is how we disaggregate. There's a lot of new technologies in what VAST is doing, but I think the thing to consider is that is almost by design. Like, we had the luxury of starting late in the storage market. We started designing the architecture in 2016. And what we didn't have to do is we didn't have to bring the baggage of the legacy architectures that would preclude the effective use of some of these new technologies. And we just had the fortune of being able to start with a clean slate. So I definitely don't view that as a detriment. And in fact, we view it very much as a strategic advantage that we're doing something that isn't possible with legacy architectures.
Yeah. And there is another question. What happens when Intel decides to stop making Optane and QLC? Well, I have to say that QLC is not on Intel only. There are other vendors doing it. So I don't think it's, there are roadmaps that are talking about years and years of development in terms of adding layers, adding, even there is, research around PLC, or I read an article the other day about 6-level cell. I mean, we are very far from having it in production, but actually we are talking about additional capacity. So QLC will never, be the problem. Intel Optane is something that is built by Intel only, so it is more. But consider that, if I'm not wrong, Intel declared a few days ago that is already a $6 billion business per year. So it's not a small business, okay? It's already adopted by major cloud providers, by startups, and even large storage vendors. There are applications that are, in the realm of extending memory. So there are Optane DIMMs that are now available to extend the memory footprint of a server, and of course everybody loves paying less for more memory. I have some customers that already adopted this model with their several vendors. So I think it's not that tomorrow we will stop seeing it, and I'm pretty sure that at that time there will somebody else that will come up with a similar solution or a different solution to solve the problem. Jeff, you are even more involved than me in this. I mean, you are using Optane.
So, there's two elements to this, two different types of media. One is high endurance buffer and metadata storage. The other is low cost flash. Today that's QLC. I think every single major flash manufacturer in the market has QLC either shipping today or on the roadmap, so that's not a consideration. It's a strange question. On the side of storage class memory, in fact, there are now 3 derivatives of storage class memory in the marketplace. Intel provides one, which is Optane. Samsung has ZNAND. Toshiba has their FL products. And so we're a software company and we work with commodity infrastructure. We don't make our own drives. And as we get to the point where we start thinking about building a billion-dollar business, you know, we have multiple sourcing options as we work with customers to build systems. So, you know, Optane is what we're using today, and we're very happy with it. But we also have other options that are equally suitable.
Okay, fantastic. So, and with this, I think it's time to close this webinar. I'm wrapping up here by telling you that you can find even additional content on GigaOM.com, including other on-demand webinars, as well as reports, especially my reports on storage. And Jeff, where we can find VAST Data or you in the social media if you want to keep the conversation going?
Sure. So I'm actually checking my Twitter handle right now because I never remember what it is. So VAST Data, you can find us at vastdata.com. Pretty simple. On Twitter, we're at VAST_data, and I'm at Jeff Denworth. So keep the questions coming, and thanks for spending the time to understand our story and understand the state of the market a little bit better.
Great. Thank you very much again, and bye-bye.